Now let's learn about properties of whole numbers, and the first property that we would discuss is the closure property. And in closure property, let's begin with addition. Okay, so the first one would be addition. For addition, so suppose you are given two integers, two whole numbers, right? You are given 2 and you are given 3. So if you add these two whole numbers, that is 2 plus 3, then what would you get? You would get 5, right? Suppose you are given 5 and 6, and if you add it, you'll get 11. You add 0 and 1, what would you get? You would get 1. So you could notice that 5, 11 and 1, these are all whole numbers, right? They all are whole numbers, and that is what the closure property is. So if this is a set of whole numbers, right? This is a set of whole numbers. This is a set of whole numbers, that is a collection of whole numbers, and if you add any two, or not only two, say if you add 3 numbers or you add 4 numbers all together, you add 5 numbers and so on. If you keep on adding whole numbers, then the resultant number, that the answer that you will get, will also be a whole number, and that is what a closure property is. That is, it is closed. It is closed within addition. It is closed within addition. That is, the resultant number, the answer, would belong to this set, that is a set of whole numbers. Now let's move to multiplication. Multiplication. So in case of addition, you would say that addition of whole numbers, addition of whole numbers is closed. That is, it follows the closure property. The closure property. Now let's move on towards multiplication. So in case of multiplication, let's take the same previous numbers. Multiplication. Let's take the same previous examples, right? So you have 2 and you have 3. Now someone asks you to multiply them, what would you get? You will get 6. You have 5 and you have to multiply with 6, you would get 30. You have 0, and if you multiply it by 1, you would get 0. Now you would notice that again, the 6, the 30 and 0, they all are whole numbers. That means that even if you multiply any numbers, right, either 2 numbers or 3 numbers or 4 numbers or 5 numbers, suppose you multiply all of these numbers, right, you multiply them, 2 by 3 multiplied by 5 multiplied by 6 multiplied by 0 multiplied by 1, since it has 0, therefore it would become 0. I mean, I just wanted to explain you that if you multiply whole numbers, then the resultant answer would also be a whole number, and therefore even multiplication of whole numbers follows closure property. Closure property. And therefore it is multiplication of whole numbers is closed. Now let's do for subtraction. Okay, so let's do for subtraction. I'm deleting this space, okay, so that I can perform some operations here. And I should have applied Control X. Anyways, so for subtraction, let's do for subtraction. Now, say you have 5 okay, and you have 3, you have 5, and you have 3. So if you subtract 3 from 5, what would you get? You would get 2. Suppose you have 2 and you subtract 1 from it, what would you get? You would get 1. If you have 1 and you subtract it from 1, what would you get? You would get 0. Okay, so even in this case I got whole number, here also I got whole number, here also I got whole number. But what if I have this 8 minus 10, and what you would get is minus 2? Is it a whole number? No, of course it's not a whole number. Let's take another example. You have 100 and you have minus 200. So the answer you would get is minus 100. Is it a whole number? No, it's not a whole number. So if you apply subtraction, then it's not sure that not every time you would get the whole number. While applying subtraction, you saw here that in this case you got the whole number, in this case you got the whole number, in this case you got the whole number, but here in these examples you didn't get the whole number, you got the negative integers, you got the negative numbers, and negative number cannot be a whole number. Therefore it's very clear that subtraction does not follow, it does not follow the closure property, right? The subtraction of whole numbers is not closed. Let's do for division. Let's do for division. Let's do for division. And division, say take you have 15, and if you divide it by 3, then you would get 5. Okay, if you have 18 and you divide it by 3, you would get 6. If you have 4 and you divide it by 2, you would get 2. But what if you have 2 and you divide it by 4? Okay, I did this for this. Would you get, what would you get? In this case you are getting 2 by 4, and if you would solve it, you would get some numbers in decimals. Okay, you will get some numbers in decimals. I'm not going to discuss that. So you could see that here it's a rational number. It's a rational number. Even in this case, if we do it here, so this was 18 divided by 3. Here you could do 3 divided by 18, and if you would do this, you will get 3 by 18, and again something in decimals. Okay, not going to discuss that. So again you saw that you would get a rational number. So not every time when you will perform the division operation, not every time you will get a whole number. Like in these cases, in these 3 examples, you got the whole numbers, but here you are getting rational numbers, and rational numbers are those numbers that could be written in the form of P divided by Q. So rational numbers are not the whole numbers. So it's very clear that even division of whole numbers do not follow the closure property. To follow the closure property means that each and every time when you perform the operation, that is in the case of addition and multiplication, when you perform the addition and multiplication on whole numbers, then each and every time the answer that you got, the resultant numbers, they all were whole numbers, and therefore they were following the closure property. But in the case of subtraction and division, not every time the resultant number or the answer was a whole number, and therefore the subtraction and division, they do not follow the closure property. And in the next video we are still left with 2 other properties, and in next video we'll learn about them also.